Hello everyone. Now we can going to discuss memory interfacing. So which is a part of computer organization. It deals with the way of connecting various levels of memory units, which is processor, input output devices, likewise. So using this memory interfacing, we can going to calculate average access time to the processor. So normally we can measuring the unit of MIPS, which is million instruction per second. So two way we can calculate that access time, that fetching time. So first way is here, the processor is connecting to the memory which is in serial way, not a sequential way, it is parallel way. So the average memory access time, which is equal to, we can here see that access time and hit ratio. Hit ratio is nothing but the total number of instructions hits in the memory. So the number of instruction is, suppose we have the total number of instruction is 100. So the memory hits only 80 means the hit ratio is 0.8 or 80%. Likewise, we can calculate that hit ratio. So the memory access time is T1 we can take, and the hit ratio is H1 we can take. So the memory is parallelly fetching to the processor. So the average memory access time is equal to H1 T1. H1 means hit ratio 1 multiplies T1, which is access time. So suppose it is not hit the memory, means that we can take 1 minus H1. So we can take 1 minus H1 multiplies hit ratio 2, which also multiplies time 2, which is access time 2. Likewise, this formula is going on. So we can use this formula for calculating average memory time access time. So the second way is also we can calculate, which is serially we can connect the memories using processor. So we can take likewise only access time T1, T2, T3 and each ratio H1, H2. So the effective access time of memory access, which is T average, which is equal to, we can multiply directly to H1 T1 these formulas. Same likewise 1 minus H1, which means not hit, that hit ratio 1, it's not fetching to the memory, means 1 minus H1, which also multiplies with H2. And we can also multiply with that access time 1 and 2, which is T1 and T2. Likewise, this formula is going, we can see this 1 minus H1, same previous formula we can apply here also. So 1 minus H1 is not heated, suppose that also multiplies with 1 minus H2, which is also not hit. Then we can multiply 3 access time T1, T2, T3. So for this formula, using this we can calculate the example. For example, we can take a cache memory needs an access time of 30 nanosecond and main memory is 150 nanosecond. So what is the average access time of CPU? Assume the hit ratio which is equal to 80%. So we can take that cache memory and main memory, which is fetches into the processor. That is one type. Then the another type is serially we connect memory and cache memory and processor. So we can going to calculate likewise. So the access time, the cache memory is 30 nanosecond, hit ratio is 80%, which is converted into 0.8. So the main memory time is 150 nanosecond. So we can apply in this formula average access time, which is equal to h cache t cache, then 1 minus h and time of main memory. TMM means main memory. So we can apply this formula 0.8 into 30, 1 minus 0.8 into 150 nanosecond. So we can calculate 54 nanosecond, which is paralleled memory method. So another method is serial method, which is access time. We can take that question itself. So the t average time is equal to h cache and t cache, 1 minus plus 1 minus h cache and t cache t main memory. So we can apply this formula. So normally 0.8 into 30 nanoseconds for t cache, then same likewise 1 minus 0.8 is then into 30 plus 150 nanosecond. So finally we can get 60 nanosecond for this answer. If the question mentioned any parallel or serial type, then we can use that formula only. Which is not mentioned anything means we can use only in this method, which is parallel method. Parallel method only we need to use, which is not mentioned anything in question means we can use parallel method. So the 60 nanosecond is the correct answer. So once again, thank you very much for this video.